Bismillahirrahmanirrahim. Welcome to the second part of this topic, which is trigonometric substitution. As we stated in the first part, we said that we have sometimes some functions for which that we cannot do it by direct integration or integration by part or integration by the normal substitution. So we need to look for another technique, which will be in this lecture, trigonometric substitution. And as we stated before, that sometimes we have three cases for the trigonometric substitution, depending on the function. If we have the square root of a square minus x square, then the substitution will be x equal to a sine x, where theta will be between minus pi over 2 to pi over 2. Why is this one? Because if we get the final answer, in some cases we need to use the inverse trigonometric function. And for the inverse sign, the domain is between minus pi over 2 to pi over 2. This substitution is related to the identity 1 minus sine square equal to cosine square. This will be used in the square root. The second form, if we have square root of a square plus x square. A square plus x square, this is related to the identity 1 plus tangent square equal to secant square. So we will use the domain or the substitution x equal to a tan theta, where theta will be between minus pi over 2 to pi over 2 over an interval. And the third form, if we have square root of x square minus a square. The first case is a square minus x square. Third case is x square minus a square. And this will be related to the identity secant square minus 1 equal to tangent square. So we are choosing x to be a secant theta, where theta will be in the first quadrant or the third quadrant, 0 to pi over 2 or pi to 3 pi over 2, with half open interval, not equal to pi over 2 and not equal to 3 pi over 2. Let's apply this in the coming examples. Let's evaluate the integral using the indicated trigonometric substitution. We need to find or evaluate this integral, or x to the power 3 divided by square root of 9 plus x squared. I have 9 plus. It is the second case. Given that, we need to use x equal to 3 tan theta. It's already given. So if we have x equal to 3 tan theta, then dx is equal to 3 secant square theta d theta. So the integration will be, now I have x to the power 3. X to the power 3 means we are going to cube 3 tan theta. It will be 27, or it is a 3 tan theta all to the power 3 divided by 9 plus 3 tan theta square multiplied by dx, which is equal to 3 secant square. D theta. This is equal to integration of 3 to the power 3 is 27 tan to the power 3 theta multiplied by 3 secant square theta d theta divided by 9. I will take, this should be 9, not 3, because we square it. It is 9. Take 9 as a common factor. It will be 1 plus tan square theta. And 1 plus tan square, this is equal to secant square. So this can be written as integration of 3 times 27 is 81 multiplied by tan to power 3 by secant square. This is divided by, this 9 will be taken out as 3. 1 plus tan square, we say it is equal to secant square. Take it out of the square root, it will be secant theta. Now we can simplify it. This 3 with 81 will be 27. And this secant will be cancelled with the square. So the integration now will be equal to 27 tangent to power 3 multiplied by secant theta d theta. Now we have tangent to power 3 and secant to power 1. And we know that if this is one of the cases that we have discussed before. If I have odd power for the tangent, I will save 1 out. So I will write it as tan square. So this can be written as 27 integration multiplied by tangent square theta times tangent to power 1. D theta. Again, if we have odd power for the tangent, we take one tangent, because I have tangent times secant theta. So I'll save one tangent and the remaining will be even power. And using the identity, tangent square is equal to secant square minus 1. This is equal to minus 1. So the integration will be 27 multiplied by tangent square, which is equal to secant square minus 1 multiplied by tan theta secant theta d theta. I know that tangent theta secant theta equal is the derivative of the secant theta. So I'm going to use integration by the substitution. Say let u equal to secant theta. This will give me du is equal to tangent theta secant theta d theta, which is equal to this part. So the integration will be 27 multiplied by u square minus 1 du. U square minus 1 du, which is equal to 27 multiplied by 1/3 u to power 3 minus u plus constant c, which can be written as 27 1/3 u is equal to secant to power 3. So this is the answer for this integration, but this is not the final answer because my question was written in terms of x variable, not theta. So if I want to write it back as x variable, we know from the beginning that we have x equal to 3 tangent theta, which means tan theta is equal to x over 3. But we know also that tangent is the opposite divided by the hypotenuse, which means that if we have right triangle, the opposite is x, hypotenuse is, sorry, it is adjacent, not the hypotenuse, over the adjacent is equal to 3. If this is theta, then the opposite is x, the adjacent is 3, and the hypotenuse is equal to x squared plus 9, or 9 plus x squared. From this relation, we have secant theta is equal to the hypotenuse, which is x squared plus 9 divided by 3. So this will give me now the final answer for the integration. is equal to, I need to replace secant theta by x squared plus 9 divided by 3. So the final answer now will be written as 27 multiplied by 1/3 secant cube, which is equal to 9 plus x squared divided by 3 to power 3 minus secant theta, that will be 9 plus x squared divided by 3 plus the constant c. So this is the integration for this function. Let's have another example. Suppose that we need to evaluate this one, x squared divided by 9 minus x squared. 9 minus x squared. This is of the form a squared minus x squared. So in this case, I will choose x to be, it is square root of 9 is equal to 3, multiplied by sine theta. We go back to see the form. It is square root of a squared minus x squared. So the substitution will be x equal to a sine theta. Or, and also we can use a cosine theta. Now for this one, dx will be 3 cosine theta d theta. So the integration now will be x squared, we are going to square this one. So I'll have 9 multiplied by sine square theta divided by 9 minus 9 square theta, or sine square theta. And also we have d theta. We shouldn't forget this one. dx is given by 3 cosine theta d theta. So the integration now will be 9 multiplied by 3 sine theta d theta divided by, I will take 9 as a common factor, then I will have 1 minus sine squared. But we know that 1 minus sine squared, this is equal to cosine squared. So this can be written as integration of 3 times 9 is 27 multiplied by sine squared theta cosine theta divided by, the 9 will be out as 3, and cosine square and under the square root will be cosine theta. Now for the cosine theta, should we take the positive or the negative outside the square root? We are taking the positive because we said from the beginning that theta, this theta, is between minus pi over 2 less than theta less than pi over 2, which is in the first quadrant and the fourth quadrant. And first and fourth quadrant, the cosine is positive, so that's why we are choosing positive cosine theta. Now we can simplify it. This cosine will cancel cosine. 3 with 27 equal to 9. Then we will have integration of 9 sine square theta d theta. So we can choose now the half angle. Sine square is 1/2 multiplied by 1 minus cosine to theta d theta, using the half angle identity. So I'll have 9 over 2 multiplied by integration of 1 is theta, and integration of cosine to theta will be minus 1/2 sine to theta. which is equal to 9 over 2 theta minus 1/2. Now sine to theta, using the double angle identity, it is equal to 2 multiplied by sine theta cosine theta plus the constancy, because this is indefinite. Now from my substitution I have x equal to 3 sine theta, which means sine theta is x over 3. But we know that sine theta is the opposite over the hypotenuse, which means if we have right triangle there, this is theta, the opposite is x, hypotenuse is equal to 3. And the third side will be 9 minus x squared. This will give me now cosine theta. Cosine theta equal to the adjacent, which is equal to 9 minus x squared divided by 3. So we can write the final answer for this one. So the integration is equal to 9 over 2. I have theta there. From this relation, we can write theta as sine inverse x over 3. We have theta, or sine theta equal to x over 3, which means theta is equal to sine inverse of x over 3. So I'm going to replace this theta by sine inverse. It is sine inverse x over 3 minus, this 2 will cancel 2. I have sine theta and cosine theta. Sine theta is given by x over 3 multiplied by cosine theta, which is equal to this one. This is the square root of 9 minus x squared divided by 3 plus the constancy. So this is the value of the given function, or the integration for the given function. Trigonometric substitution, evaluate it, then at the end write it back in terms of x using the right triangle. Find the sine theta, cosine theta, and if we have theta, we have to use the inverse trigonometric function.